use the microphone. My voice is loud enough. All right. That's good. Okay, this is the chair, and ladies and gentlemen, good afternoon. Today I would like to present my research about our best dynamic digital game learning scenario corresponding to the individual learning big data. At least today's online, I will give the introduction and the algorithm or system we propose, then we will give a conclusion. The first is introduction, because we always know to teach students is difficult, especially if the teaching content is boring. For example, if you teach mathematics, most students will sleep very quickly. So we know different learning between different people, especially even the same teaching content in different countries with multimedia will be much popular. Especially if you use a video as a teaching content, you will be have more attention from your students than you only use a textbook. So by using digital games, especially today's students like to play the online games or digital games. So if we can use the digital games, then the learning motivation of the student can be enhanced because they would like to play. They would pay more attention in playing. So we would like to implement or to develop the students. They can learn without any feel about learning. They would like to learn in playing. So in this research, we use a multimedia gun learning system. Okay. We use the RPG game learning for the student individually. So they can use the game to learn no matter mathematical or natural or even science. Okay. We hope we can give the teaching in playing, not only in learning. So we also design our teaching content based on the education theory, from the simple to the complexity, or from easier to the hard. So we have some issues. The first, learning platform should be easy to access. So even a primary school student can use their mobile device or use personal computers. Then they can connect to our learning platform. And second, this learning platform should be connected anytime, anywhere. So the student can have their continuous learning or do their after school assignment anytime. The third is for us, we are engineers. We need to maintain this playing platform. And this platform should be easier to be maintained, because if it is too hard, it also means we cannot change or we cannot improve it easily. So we need to maintain this platform anytime, anywhere. So, especially if we want to teach different students, because they have their own learning ability. So our platform should provide a suitable teaching content. Maybe the same teaching unit, but the content will be easier, medium, or much harder for different students. We should provide the teaching contents corresponding to each student's learning ability. So, especially since it is a game, so we should not give an end of the game. We should provide further learning. So we will continuously provide a further learning game or scenario for the student. So the student will, maybe he just interested, so he will do the mathematical game continuously. One day he will find, okay, he already do a lot of game and he already learned a lot of teaching contents and without any teacher or taught by the teacher. So this today's our algorithm. We try to choose the suitable teaching content or teaching unit. For example, from primary school, first chapter, second chapter. Then we will define the goal of the teaching activity. Then we will try to use an RPG game design a scenario or a mission, a game mission for the students. Students have to solve the problem or solve the mission. Then we can evaluate each student. Maybe you are good, you are good enough, or you are better, best, you are not, you are fail. All is possible. So we will design the scenario. Then we will design the whole platform, game platform, from the first scenario to the maybe to the end scenario, from the simple to the complex. Okay. And to provide a suitable learning content corresponding to the individual learner, we need to evaluate each student first, because we cannot provide a too hard teaching content to a student and he cannot solve any solve any problems or solve any questions. Then he will lose his interest or he lose his motivation quickly. So we try to use we propose the dynamical design algorithm. We base on the ratio of correct. First, ratio of the correct answer, and second, the total testing time of individual learner. We evaluate a student learning ability based on first how many questions you answer correctly and how much time you spend to answer these questions. If you can answer the question quickly and with more correct answers, it means you have a better learning ability in this subject. This is a definition of a parameter we use in our algorithm. So the first, we will try to collect all the students use the learning platform. Their data will be our source to create the threshold. Okay, the learning style of a learner will record it in a database, so we can use different. We can collect and merge all the students' learning state. Then we can evaluate and we can count the average, for example, average correct answer in this subject or average answer time in this subject. So we can use this all data to evaluate how much time or how many questions you should correctly answer. Then we can evaluate one student. You are better in the 70% or you are better in only about 30%. So every student will be classified in the beginning. Then we will provide the corresponding teaching content to each individual student. Maybe they learn the same thing, but the teaching content will be easier or will be harder. We can use this to evaluate one student. Like this is our algorithm. Maybe I can stay with it as soon as possible. Then, by using the algorithm, all students will be allocated questions. Either we exam or we give a test to the individual student. We will also, because we want to keep the motivation or interesting from the students to learning, so we will give different learning content and different different questions to different students. Then the students will not lose learning interest or motivation or patience. Okay, here's our structure. A system user or a student, he just use the web browser. Then he can log in from via internet to our virtual machine. We have a cloud platform, so we can create different virtual machines to different students. Then all the learning system middleware, it will be the same, but we will evaluate each student according to the data in our cloud database. So if you are a new user, we will give a new test in the beginning. If you already use the platform for several times or you have used for a long time, then your data will be recorded in our cloud database. Your data will be used to management and to use the dynamic count as our threshold. Also, your learning ability, or we say your data, will be used to trigger a new scenario, learning scenario, corresponding to your learning ability. It's our some scenario, just a picture from our systems. And the system, we can provide a game based on education theory. In fact, we already implement our platform in the cloud, and we provide the learning system to several primary school students. Okay. Without a doubt, students always like to play. So they will pay more times in playing, not in learning in the classroom. So by using the dynamical assignment algorithm, students will find, hey, why we learn the same chapter, but your teaching content in the brain system is not the same as me, as mine. So they will have different learning. We will let a different student to learn the teaching content corresponding to their learning ability. So we can collect a huge data, and we can use to analyze first the teaching content is good enough or is suitable to provide the student. And the second is student is given correctly corresponding to the teaching content. If possible, I will just I hope the internet is. We use so you're a student. Okay. 那我还要新增，出来新增。He's my master student. Yes. So a student just use the browser, eventually IE or the Chrome. They just use the browser and log in by their own Google account. Then they can log into our virtual machines. So we don't need a lot of installation. But today we only provide a 2D RPG games. Okay, we will require the personal information from Google. Then we will use this personal information and create an account in our cloud database. So your learning state will be step by step recorded in our database. So we will need to spend a lot of time. Now it is our it's a virtual machine in cloud in the National Open University. So now we already log into the virtual machine, and we can start the game. So the student just need to remember their account and their password. Then they can log into the game anytime, anywhere. If you already learn, we will recall the data corresponding to the time. So we will 这是一开始嘛， It's just the initialization figure. We can provide in Chinese, in English, they will be fine. And we also implement about voice recognition for your English learning or for your Chinese language learning. We are so you can use your microphone to to pronounce the word, the vocabulary, and our game system will respond you correctly or not. But today we only have the 2D because 3D engine costs a lot of resources. Okay, that's today's presentation. Thank you. Thank you for your attention.
Okay, let's give a big hand to Mr. John. Anyone has any question for Mr. John? start first. Yeah, it's very interesting. I don't know if the system is open for public or just in your university.
In fact, if we provide the connection, it means everyone can connect to our system.
How many the system allow how many users enter the system, because the cloud and the big data, so each one can play based on its learning capability. Then you can switch to different scenario, right? So how many? Yeah.
In fact, we provide the game platform in Linux-based system in a virtual machine. So based on the hardware we have now, we can provide about 15 to 20 students at the same time. And all the data will be recorded in another system, not in the cloud platform. So it's different. We try to reduce the resource consumption. Yeah.
The loading, I see. Because most of the class size is around 50 or 60 students.
Yeah.
So that's gonna be the challenge.
So only around 15 small size class.
Yes.
Yeah.
Yes.
Maybe just switch, right? You can separate the class into 40.
Yes.
Yeah, they can use the system. Another thing, the last one is how big is the data? I mean, generally from those 15 students, when they finish the session, how big is the data? I mean, just a rough size.
In fact, we if playing the game, and in each chapter we will record the learning state, chapter by chapter, step by step. So in fact, we don't have a very huge in single data, because each single data is small, too small. It's only about several K.
You mean for each person?
Yeah,
Yeah,
each person, each chapter.
Right.
So each individual data is small.
Yeah. Actually, once the class size getting bigger and bigger,
then the scenario and the data then gonna be
Yes, so
flooded. Your system will be flooded with the data.
Yes, so we provide to the primary school, and we hope we can create more data and test our systems.
Yeah, interesting, very interesting. Yeah, any other question for anyone here? Well, then, yeah, thank you so much. Yeah, thank you. Thank you.